So far, we saw the transfer of electrons taking place between the objects that are electrically charged. Now, the question is, how do we know that if an object is carrying charges or not? How will we get to know whether an object is electrically charged or not? See, we understood the concept that when an object is charged, um, it has excess of electrons or less number of electrons. Only then it is charged. But the question is, we cannot see electrons, we cannot see protons with our naked eye. So how do we get to know that okay, this object is charged and the other object is not, or that object is not? So for that purpose, we have a very simple device which tells us in a very simple way that an object is electrically charged or not. So this device is called electroscope. So let's see what what is electroscope, how it's working. Okay, so it's a device to test if an object is carrying a charge or not. So it will not really tell you whether the object is carrying a positive charge or a negative charge, but at least it will tell you whether the object is carrying a charge or not. So it will actually distinguish an object in two sections, a charged object and uncharged object. So let's see how exactly electroscope works. Now, there are many types of electroscopes. The common type of electroscope is gold leaf electroscope. So let's first look at its structure. It consists of a glass bottle, okay, and then you can see here there is a rod, vertical rod, right? And this vertical rod is made of brass, okay, and a metal. Okay, this is a metal rod, and this from this vertical rod we are having here a disc. You can see here, and in the downward direction from this vertical rod we are having two parallel strips of thin flexible gold leaves, and at the top there is a disc. That means located at the top of a mouth, at the mouth is a disc. And what is the purpose of this disc? This disc actually provides a platform where the object for which you want to test, say suppose I want to test this object, so the object to be tested is struck or is beaten on this disc, okay. And these two leaves which are connected to the brass rod at the bottom, these are parallel strips of gold leaf. You can see the leaf like structures, right? So these leaves are nothing but they are made of metal gold, and these are called gold leaves. So that is why this electroscope is called gold leaf electroscope. And these two strips are extremely thin. They are kind of located parallel to each other, okay. So whenever we have to test an object is charged or not, so that object is brought in contact like this with the disc. That is brought in contact with this disc directly, and the disc is in contact with the brass rod, right? And the brass rod is connected with these gold leaves, and that is how the arrangement is. Now let us suppose we want to know whether this object is charged or not. So what you have to do, just beat or struck this object on the disc. Now what happens when the object is stuck on this disc? Let's assume this object is positively charged. So in that case, as soon as you bring this near the disc, negative charges will tend to come on the outer side, will tend to appear on this disc, because opposite charges attract each other, right? So these negative charges will be coming here. Now negative charge will be coming here on this disc. What will happen? There will be attraction between the positive charges and the negative charges, right? Because all the negative charges are coming on this side. Now what will happen to the positive charges present here? Because negative charges are coming here. Now where will the positive charges go? The positive charges will tend to move on the other side, will tend to move here. negative charges will move here and positive charges will move here, because positive will repel these positive charges, right? They will appear here, they will move on this side. So as a result, the same charges will be seen on both the metal leaves. And now when both the gold leaves are having positive charge, what do you expect these leaves to? How will they behave? Definitely like charge repel each other. So these leaves will tend to move away from each other. As I mentioned before also, these leaves are extremely thin. Now when they are very thin and light also, so they are like very easily, they can move near each other and they can go away from each other. So when both of them will carry like charges, so they tend to repel each other. So whenever this object which is under test, if that object is carrying a charge, in that case the same charge, for example, here the object is positively charged, so the gold leaves are also getting the positively charged, right? So in this object would have been, if in that case, if the object would have been negatively charged, in that case then there also negative charges would come, right? Because if this has been negatively charged, then positive charge will appear here and negative charges will repel, they will appear here. So when both the gold leaves are negatively charged, again same thing happens, gold leaves will repel each other, right? So these gold leaves will move away from each other, right? So this is how will this electroscope tells us that an object under test is charged or not. So whenever leaves separate from each other, that would mean the object is charged. So whenever the leaves separate or they repel away from each other, that would indicate that the object under test is charged. And if the leaves do not separate, or if they remain like this, that would mean that the object is not charged. Now, do you understood how these charges are basically getting conducted? They are getting conducted through this metal conductor, right? Because metal conductors, what will happen? Metal conductors will allow the charge to flow through them. So the charges are basically coming to the disc, and from the disc, it's conducted through this terminal, and the metal rod finally reaches to the leaves, right? So basically charges are moving along this rod, okay? So therefore the leaves are getting same type of charge as is present on the object, okay? So this is how an electroscope works. Now let us suppose what will happen if the object is neutral. If suppose this object is not carrying any charge, so in that case there will be no charge which will be coming here, right? And as a result the leaves will not separate. Now another thing that you can observe is, instead of touching the disc with this object, if you touch the terminal, if you touch this disc with your finger or with your skin, what will happen? See, the human body is a good conductor, right? So whenever you touch it with your finger, charges will get apart. Charges will immediately flow through the human body because you are a good conductor, and charges will go to the earth, and as a result gold leaves will lose all the charges that it had accrued, and the gold leaves will come close together, right? So they will no more separate away from each other. So that is how the gold leaves will lose the charge, because the charge which it had accrued in this fashion, it will lose all the charge if you touch it by your skin or by your finger, okay? So basically you understood the working of electroscope with the help of these metal leaves, whether they are separating or not. Looking at that, you can tell whether the object is carrying a charge or not. Even you can yourself also try to design a very simple electroscope for yourself. All that you need a piece of cardboard, and you need an empty bottle jar. Then you place the cardboard piece on the mouth of this empty bottle jar, and you need a wire, right? Maybe for that you can use a paper clip. So here it's a paper clip, okay? Just straighten it and then put it like this through the hole in the cardboard, okay? Then you can have the two strips of aluminum foil. Now instead of gold leaf, because you are not having here gold leaf, you can make use of aluminum foil strips. They are quite light and they easily come together or go away from each other. Now in this case, this is the end of the metal wire here. So the charged object has to be brought in contact with this metal wire. So let us suppose we bring this charged object, this rifle, near this end of wire. Okay. So whenever we bring it near, the charge will get conducted through the metal wire and it will reach to the aluminum strips. The aluminum strips will receive the same type of charge and they will tend to move away from each other. So when they move away, you get an indication that okay, this object is electrically charged because the foil receives the same charge from the charged object through the paper clip. So that's how you can design a simple electroscope for yourself.